So this is notes 2.1 and 2.2. We start into the logic of everything in geometry. So we're going to start right off with a little bit of a warm-up first. If these, I want you to figure out whether these are true or false. So pause the video and then do them. Okay, how'd you do? Did you get true for the first one? I mean, that one's pretty straightforward. B's in between A and C, and it has to be on the same line if it's between A and C. But B is between A and C. B being the midpoint is false. So this is my reason for my false answer. We're going to find out this is called a counterexample. So if there's anything that disproves a statement, that's a counterexample. Some examples of that are, we always have dinner at 5. Well, yesterday we had dinner at 7. So that would be my counterexample. The statement I made is false. So the objective today is using conjectures and counterexamples with inductive reasoning. Here's some of these words. Inductive reasoning is just a process of making a prediction based on specific examples or things that have happened that are very specific and very clear. It's like a pattern. We see a pattern happening. Conjecture is an educated guess that's based on known information. So the conjecture in this problem up here was that B is between A and C, then B has to be the midpoint of AC. Well, that's my conjecture, is what this is called. But as we can see, conjectures, like number 1, can be true or they can be false. And a counterexample is just something that shows a conjecture to be false. So I want you to pause the video, see if you can make a conjecture or make a statement about the pattern that's happening here, and then use the conjecture to find the next item. Okay, did you notice? So we're always multiplying by 2, by 3, by 4, so the next one must be by 5. So that would be 240. So the conjecture, yours could be different than mine. In fact, the process could actually be different too, but it should be something that is predictable, that says what's happening. And then you're going to use inductive reasoning based on that pattern to find the next item. Okay, here's another one. Let's see if you can pick up this pattern. Pause the video, try it. Okay, did you pick up? So the number in the denominator is always squared, and it matches the sequence number. So I said the sequence number is squared in the denominator, so the next number in the sequence is 1 over 36. Same thing for this one. Now we pull in the geometry vocabulary and the symbols. So I want you to try to draw a figure to match this picture. Look at the figure, make sure it makes sense, and then make a conjecture. A conjecture could be anything that you observe, so it's what you see. All right. So my conjecture was LM was the longest side of the triangle. Did you start drawing it like this one? That one didn't work out, did it? Because you get these lengths in there, so you have to kind of fidget with things a little bit. I had to put a line over LM to make it correct, so make sure you're doing your symbols correctly when you work on these conjectures. Okay, so for this one, try this. Well, here's my conjecture. My conjecture for this is AC and CE are legs, or AE is the hypotenuse, because it asks us to draw a right triangle. So that's the way my picture turned out, and that's my conjectures. You might have something different. All right, try this one. So if you use inductive reasoning on this, you do a couple patterns and see if a couple problems, see if it works. The product of 2 odd numbers is odd, so that's our conjecture. And then there's this one. Try this one. So this one is asking for a counterexample to this conjecture. Here's the conjecture. The unemployment rate is highest in the counties with the most people. Well, if you look at Perry is a low population, but it has a high unemployment rate. So this conjecture, this is our counterexample, and we would call that as a false conjecture. So the next step in this is to look at conjectures and find a counterexample. What would make this a false statement? So you're trying to disprove this. That's what a counterexample is again. So try to draw a picture that would be a counterexample to this. So both of these are false conjectures because we can disprove them with a counterexample. So if I say to find a counterexample to disprove if these are false, then that's what you do. You draw a picture, you write words, you come up with symbols that prove it. The next part of this is notes to 2. So this one we start into things called truth values. So what we do is we assign some symbols to some statements. This statement has a P assigned to it. This one is Q. This one is R. So it may or may not be true, but we're going to look at these. So 1 foot is 14 inches. That would be false. September has 30 days. That's true. A plane is defined by 3 non-collinear points. Yeah, that's the definition, so it's true. Then we have the negation symbol. This is the opposite meaning or the truth value. So the opposite of that P statement, 1 foot is 14 inches, is 1 foot is not 14 inches. So if there isn't a knot in there, you put 1 in. And if there is a knot, you take it out. So try to do the negation statements for the Q statement and the R statement on your own. Pause the video. All right, how'd you do? So you just rewrote the sentences and put not in there. And also notice I put the true and false of each of these statements. So these are called not statements or negations. These again are just the statements. So now we're going to learn about using these symbols to write conjunctions and disjunctions. Whenever you see this little symbol right here with the up, it goes with and I like to write and with a capital because it kind of matches that. A conjunction is true only when both statements are true. A disjunction is an or. That's the opposite version. It's upside down, or it's a V. And it's in reverse of the other one. A disjunction is true if at least one of the statements is true. So just one has to be true in here. And for a conjunction, both statements have to be true. So we're going to use that on these two statements here. The P statement is 1 foot is 14 inches. The Q statement is September has 30 days. So 1 foot is 14 inches. That would be false. September has 30 days. That will be true. This symbol goes with and, so I'll put a capital there. For and, both of these things have to be true. So what I'm going to do with this is I'm going to change the P to an F. This is false. And that goes with the true in a conjunction with the and. So there's our words again, conjunction. And so both of these have to be true, so the truth value of this is that it's false, because both have to be true. Then we'll do the conjunction of this. So this one is a false statement, making a conjunction an or. So one or the other has to be true in order for this to be true. And one of them is, so this is true. So this is one or the other. So now we're going to use this on here. You try this one. See if you can get this figured out. So P is a prime number. That one is true. Q says 9 is an odd number. Oops, sorry, that's false on the first one. True on the second one, false on the first one. 9 is not a prime number. Prime numbers are the ones that are divisible only by 1. Okay, you try to set these up. Before we answer that, I need you to correct something on here. You're going to write a conjunction and or disjunction. So this is what we mean by writing the conjunction. You need to write a statement that shows that you understand the meaning of that. So correct that if you would. All right, so for this one, the conjunction is 9 is a prime number and odd. Well, this is false for P. It's true for Q. So the truth value of this is both of them have to be true in order for this to be true. So that would be false. For this one, it's asking about not P. So not P, or the negation of P, is 9 is not a prime number. So that one is true. So we're going to change this a little bit. It's 9 is not a prime number. and is odd. So that's true for both of those, true and true. Therefore, the truth value, since this is a conjunction with the and, is true because both of them have to be true. So now we're going to combine these a little bit, just like we would with equations. The parentheses mean to do that first. So we're going to try that with this statement. The first thing I'll do with this is I'll figure out the truth values. So AB, with the line segment over the top, is proper notation for segment AB. So that would be true. The opposite of this has to be false. Q says centimeters are metric units. Yeah, that's true. So the opposite of that is false. And then for R, 9 is a prime number. Not true. So the opposite of that is true. So we set those up. Then we just go like this. P is true. The P and Q, both of them have to be true, right? So because that's the case, so we have a true. But we're still combining that with the truth value of the R, which is false. So now I have a truth value of true or false, because this is a disjunction. So this one or the other has to be true. So overall this is true. You try the next one. For the next one, I just substituted the truth value in for each of those P, Q, and R symbols. It's not P. Not P is false. And if I have a false and a true, they both have to be true in order for this to be true. So this is false. Then I'm comparing that with F or F. So that would be false. So if they're both false, then the whole thing is false. Okay, P or Q is the next way we read this one. So P is true, or Q, which is true. So that would be true, because one or the other has to be true. And then I'm going to compare that with the opposite of R, which is true. So this one is true. Next one, R, is false. False with a false turns into false. Not P is F, or the opposite of P. Negation of P is F. And a Q, which is T, true. So this is an and. Both of them have to be true. So this is false because both of them are not true. Then I'm combining those together, and I get F. So before we move on, just remember a conjunction. Both of these have to be true in order for the truths or the statement to be true. And then the or just has to do with or. So think about it, I had a muffin or a taco for breakfast. So I had a muffin for breakfast. So yeah, the statement I just made was true. So we're testing whether the conjunction statement or the disjunction statement is true. So is it true that 1 foot is 14 inches and September has 14 days? Well, no, it's not, because 1 foot is 14 inches. But if I say either 1 foot is 14 inches or September has 14 days, you got something to say with that. Yeah, September has 14 days, so that's true. One thing I want to point out is if you have this one, a disjunction where both are false. So I didn't have a taco and I didn't have a muffin, or I didn't have a muffin for breakfast. If both of those are false, then yeah, the whole statement's false. All right, the next part of this I'm going to save for part B of this video. So make sure you key into the next one.